So in this video, I'm going to review even and odd functions. This is a review because we already took this up, okay, in the classroom before the closure. So this is just a review for some. So even functions, say for example, you're given a function f of x equals whatever, okay. And then the meaning of even function, the textbook meaning of even function is given this f of x, okay, when you have f of x, okay, and then you substitute a value for any value for that function, then you're going to get the answer. Now, if you substitute the negative of what you substituted first, okay, negative, and you substitute it here, you will get the same answer. Okay, when that happens, again, if you think of a number and substitute it here, you get an answer. If you substitute the negative of that number to the given function and you get the same answer, then that means these two functions, the function is even. Okay, when this is equal, that means the function is even. So let's try out some functions here and see if they are odd or even. Okay, so say for example, we have, let's try simple ones. F of x equals x squared plus x. Okay, and let's try f of x equals x squared or x to the 4 plus 3x squared plus 2, and f of x equals, let's just say x to the 3. Okay, so if you think of any number, let's say 1, which is the easiest, substitute it here, okay, then you will get an answer. Then substitute negative 1 here and see if you will get the same answer. Also here and here. So pause the video and try to do that. So if you substitute negative 1 here, that will be 1, and that will be, oh no, if you substitute 1, so for this one, okay, this one, f of 1 is equal to 1 plus 1 is 2. F of negative 1 is 0. Okay, you substitute negative 1 here. So this is not an even function, okay, because they are not equal. Here, if you substitute f of 1, you're going to get 6. If you substitute negative 1, remember, a negative raised to an even power is the same, right? Would be the same as if it's a positive, the same number raised to the same power. So this will still be 1. This will still be 1 times 3. So this is still 6. Okay, here f of 1 is 1 and f of negative 1 is negative 1. Okay, so in these 3 given examples, okay, the only even function is this one. Okay, so if we are going to look on patterns here, so the shortcut way, if you like to get a shortcut of how to determine whether a function is even, is 1, okay? The functions should all be even. There should be no odd. Okay, this is 1, this odd. So all the exponents are even, and there may or may not be a constant. The constant doesn't change because if you substitute the positive of a number here, you'll get a number. If you substitute the negative, it's still the same. Okay, so all exponents are even. These are just shortcut. If you like, this is, like I said, this is the textbook definition. And you could have with or without constants. Okay, so constant, or that free number there. That's called a constant. Okay, graphically, okay, it would be symmetrical with y-axis. Symmetrical with y-axis. I hope you know what is symmetry. Okay, what you see on the right of the y, okay, you will just do the mirror image on the other side of the y-axis. So if you have like this, okay, like that, so you just fold your paper and see the traces of this on the other side. So you're going to have something like this, like that. Okay, so that is symmetrical with y-axis. Okay, for the odd function, the definition for the odd is, if you think of a number and substitute it in the given, you will get an answer. If you substitute the negative of that number and substitute it in the given function, you will get the negative of your first answer. Okay? So you see the difference here. Okay. So if we see at these examples here, which one is an odd function, okay? When we substitute a positive number, we will get an answer. When you substitute a negative of that number, you will get the negative of your first answer. So this is an odd function. This is an odd function, okay? So this one, no, it has to be, this is the same for even, but here, this should be negative of this. Okay, I hope you understand that. So, so again, for the odd, all exponents are odd, should be odd. Let's try that, okay? So if we put an x here, which is another odd, let's just put an example, is f of x, x cubed plus x, still odd. If we add an x there, would that still be odd? So what is f of 1? That is 1 to the third plus 1 is 2. What is f of negative 2? That will be negative 2 to the third is negative 8. Oh no, negative 1, sorry. Okay. F of 1 is 2. F of negative 1, so that's negative 1 to the third is negative 1. And negative 1 is negative of this, negative 2. So it's still odd. Okay, but try to make this x squared. You will see it will not follow this rule anymore. I cannot show it here because I have to keep this short. Okay, what about if we add, let's say another function, if we add a number here, let's say plus 1 or plus 2. So f of 1 will be 1 plus 2 is 4. And f of negative 1 will be negative 1, negative 2. This will be 0. So it's not anymore. So there should be no constant. Okay. So all exponents are odd and no constant. And then, okay, so again, the difference, this is all exponents are even with or without a constant. All exponents are odd, no constant. And graphically, that will be symmetrical with origin or 0, 0. Okay, what does it look like if it is symmetrical with the origin? Okay, any graph that is symmetrical with the origin. Okay, so you can look at it different ways. Okay, so say for example, this is what you see on the other side of y. Okay. What I do is I will reflect that on the y-axis. Okay. So fold it and put it on the other side, and then I will reflect it again over the x-axis. So it will be like this. So if I see a graph like this, then I know that that is symmetrical with the origin. So if this graph is symmetrical with the origin, okay, because it is this one reflected here, okay, and that one is symmetrical. Or some students say if they have this point, let's say this point is x and a, on the other side you will find a negative x, which means to say, and negative a. It depends how you look at it. Okay, so if all your xa's here become negative x and negative a, then that's symmetrical with the origin.